Okay, let's begin. Right. So, thanks for joining me here on this very warm Thursday afternoon. Right. First and foremost, hello. Hi, my name is Jason. You can call me teacher Jason, Mr. Pang, whichever. Right, or just Joe. Okay. So, get my attention anytime you all wish to. As we move through these four topics here. We have a couple of friends joining us at home. Can I just have a thumbs up or something to know that you are hearing and seeing me clearly? Awesome, thank you. And just keep in mind that even as you are joining us at home, if you have any questions, please feel free to type it in the chat and I'll get to you as soon as you can. Right, so can I just ask two questions first? Are we sure that these four questions are coming up for WAs? Okay, so as with all my Sec 4 classes, I like to share this one thing. Even if it is not, we are all working towards one goal anyway, right? Towards our O levels at the end of the year. Okay, so whatever revision we will have, we will get them. Okay, so let's get them going. Is there someone else joining us? Hello, please come and have a seat. How many is that? Two? Two people? One and two? Okay, we're gonna squeeze a little bit, ladies. So help me to squeeze a little bit. There will be. Is there one more chair there? No? Can you help me to go to that classroom over there, please? Thank you. You can actually see here if you want. Okay. Okay, so we will look at the questions together. So I'll use the questions. Thank you so much to recap with all of you. I Okay, we will try to be as clear as we can. Any questions, I really, really would love to hear from you all, right? Because learning will definitely be two ways. And hi, your name is? Zishen. Okay, I'm feeding your copy out now, so just give me a second. Okay, all right. So let's get this going. Homeostasis and hormones. Negative feedback. Negative feedback. Okay, so over here, negative feedback. I always like to teach it in just three very simple words. Negative feedback simply serves to. It'd be great if you all can jot down all these wonderful little points as I share along. Yeah, wait, it's printing, it's printing. It's printing, yeah. Okay. So when we see negative feedback, the idea is just hey, reversing the change. What does the change here refer to? This would be the stimulus. Okay, this would be the stimulus. Did you get extra? Oh, just really. Oh, okay, can. Oh, you just put it on side first time. Okay. All right, awesome. So reversing the change, that is our stimulus here. So negative feedback causes us to reverse the change. If I say that something has changed, means I'm always referencing from an image, a template first, right? So in your syllabus, what do we call this template? What do we call this thing that we refer to in this topic of homeostasis? I have 15 beautiful minds here. Can I have an answer, please? Change from the what? In this topic here. Change from the environment. The norm. Thank you. You are? Your name is? Erica. Thank you, Erica. Right. So we're looking at the norm. Okay. Right. However, you see that in my four options here, we do not have the word norm. It is therefore represented by the word set point. Okay, the word set point or the word norm refers to the same idea here in this topic of homeostasis. Okay, but I much rather I much rather think of it as a norm instead of a set point, because set point kind of indicates to me there's a certain number, right? But our internal environment is never a single number. For example, right, we have our body temperature. Tanya, what is our regular body temperature? 37 degrees Celsius. If then 37.1, wow, are you sick already? No, right? So we're looking at a range of values, and that's the idea I want us to have for the idea of what a norm is, instead of a single value as a set point. All right, okay, so very simple. If you're looking at reversing the change, we are going to change back. That's what we're looking for, change back, not change away. Not change away. And it is not going to be a new set point, a new norm. It's not going to be a new norm. And we can never prevent changes. Changes will always occur. What are we trying to prevent instead is major changes. right? So that's the entire meaning behind homeostasis. So this gives me an opportunity to have us jog our memory for the definition of homeostasis. If you help me, please. Definition of homeostasis, please. Let me start you off with the first two words. The maintenance. I'm missing one word there. A maintenance of a... Okay, you're mumbling. Come, help me out, please. Very good. A constant, stable internal environment. Okay, wonderful. Thank you. Right. So keep that in mind. Constant, stable environment. Maintenance of a constant, stable environment. Thank you. Okay. Right. So the idea here is more of stability and consistency within that norm, not just a specific number. All right. Wonderful. Let's move on. So for question one, it's definitely going to be A. Okay. And if you have any questions, come in. Just come in. Okay, you can bring her in if you want to. Okay. All right. Let's move on. At any point, if you want to ask any questions, please ask. Hi. We gotta squeeze a little bit more. Chairs from the neighboring classroom. Okay. All right. So here we're looking at negative feedback again. And if we keep in mind the idea of reversing the change, this is exactly what I did not want us to picture when we think of homeostasis as a set point. It will never be this. We will never be able to prevent changes. Okay. So quite obviously, I hope that we will all choose this when we arrive at this topic over here. Maybe you can squeeze into the second row or something. Ladies, help me to squeeze or the last row. Actually, last row. Here already got 5 people already. Last row, please. Last row, last. Okay. So this one is definitely going to be our homeostatic feedback. If I were to zoom in, if you can lend me your eyes for a little bit, what I can show you over here is this. Okay, no. Anything within this red arrow will be the normal value. Well, anything within this red highlight, anything within this red highlight will be considered normal values. So therefore, if I increase within this range, there will be no corrective mechanisms. Okay, there will be no corrective mechanisms because I am not above the norm, neither am I below the norm yet. So only in values, outside the red highlights. Oh, then something is wrong already. There's a drastic change. I want to prevent that drastic change. Okay, but changes will definitely occur. All right. So jumping straight into this, this one is very straightforward. I just want to bring our attention to that. Okay, internal structure of the human skin. I do not know if it is habit for you, but I would like to request that whenever we see diagrams with labels but not identified for us, can I give you 30 seconds to identify our 5 letters over here, please? If you need zoom in, I zoom in for you here already. You can use that. All right, take this 30 seconds or so to identify any of these 5 letters. Hearing all the correct answers already. Okay. Can I invite you in gray at the back? Hi, can you help me out there, please? Give me 2 letters and identify them for me. Y is the... Excellent. Thank you for correcting yourself. Right. So there's a sweat duct. Okay. Right. So there's the W is the head, Y is the sweat duct, and Batman Bugs Bunny. Hi. It's on the shirt. 2 letters, please. I mean, not X. All right, thank you for correcting yourself. Z is the arterial and it is a muscle. It is called the hair erector muscle. Okay, last but not least. Forgot your name, sorry. Jingshan, come. X is the nerve ending. Very good. And the nerve endings here paying special attention, this will be where we have our something. 4 people. Alright, please get a chair for yourself from that classroom. I think really have to squeeze besides chair again. Okay. What is inside the nerve endings here? What is relevant to the nerve endings over here? It is the function of nerve endings. Function of nerve endings. Pachanga beside you. Hi. In the brown top. Function of the nerve endings. What would it be for? Detect something. Changes in temperature. What do we call the thing that detects changes in temperature? Thermoreceptors. So here will be thermoreceptors. Okay. Right? Can I ask you to do question 3 for a few seconds while I deal with something on Zoom first? Give me a second. Yes. Okay, can you help me to go to the printer just there? Thank you. Yeah. Here. You come, please pass it to the back. Thank you. Okay, so here we are looking at air condition to sunny beach. Air condition to sunny beach. Okay, all right. So here we're looking at from air conditioner to sunny beach. So definitely it's going to be a warmer place. In a warm place, we will always try to lose more heat and something else. We're going to try to gain more heat as well, or to release more heat from within as well. Okay, so that's where our metabolic processes will increase in their rates, right? Respiration increases and many other processes. Okay, so over here, a fairly straightforward. Erica, the friend to your right. Pretty. Question 3, answer is D. D for dog, is it? So sweat duct increase in flow. Can you tell me why? Okay, so thank you for specifying water in sweat, right? Because the entire sweat doesn't evaporate. It's the water in sweat that evaporates, cooling down the skin surface. So this first part is correct, and we have relaxation of V. All right, the hair erector muscle relaxes, and when the hair strand falls, it traps less air, right? Air will still be trapped no matter how much. There will always be a layer of air. It's just how thick or thin only, right? So when the hair erector muscle relaxes, the hair falls closer to the skin surface, trap less air. This is as though you are wearing a thinner jacket, but you're always wearing a jacket. Okay, wonderful. Answer is D. Okay, awesome. Let's go. And okay, two organs secrete substances which affect the body. Once we look at secretion of substances, we're definitely looking towards homeostasis already. So here we're looking at negative feedback. And once more, the first thing I shared with all of us here today, negative feedback, you just need to remember three words. We are trying to reverse the change. Okay, we're just trying to reverse the change. And here, how can these four things, organ 1, product 1, organ 2, product 2, work together to allow for this negative feedback to occur? So negative feedback means I want to stop something from happening once a lot of it has happened. Can we try and understand that story? Right? Negative feedback, I want to stop something from happening once a lot of that something has happened. So if you look at the first one, counteracts. Counteracts means to work in the opposite direction of, kinda. So if product 1 works in the opposite direction of product 2, let's say product 1 increases value X. Product 2 decreases value X. How would organ 1 and 2 know when to release more product 1 or more product 2? We don't have that, isn't it? Right? We don't have that relationship between the two organs. So definitely this is not going to be in. Now, reinforces the effect of product 2. So if product 2 is to increase something, product 1 will increase something also. So they're kind of like working together to keep on increasing that something or keep on decreasing that something. That's not what we want, isn't it? We want to have that negative, the reversing effect. Right? So over here, we're looking at C. Inhibits organ 1, stimulates organ 2. So if you look at some product 2 inhibits organ 1. So this one, if high concentration, I will stop organ 1 from producing product 1. What does product 1 do? Product 1 stimulates this. So let me just paint you a story right now. When organ 1 is stimulated to release its product, the product 1 will stimulate organ 2, which releases more product 2. However, when there's too much of product 2 already, this function has been achieved. If this is not stopped, this flow will keep on occurring, which will result in there being too much product 2. Are we following? All right, so the idea here, if I were to give you a real life example, this is our kind of like our growth hormones. So if you just think of product 1 and 2 as growth hormones, right? Organ 1, usually what is the highest level of endocrine gland in our body? It's right here. It is not the brain. It is very high up. Hypothalamus, thank you. Right, so if you think of organ 1 as hypothalamus, and it releases, this one don't need to remember too much. Growth hormone releasing hormone. What does this hormone, what does the growth hormone releasing hormone stimulate? What's the next organ? The second level. Below the hypothalamus, what's the second highest level in terms of the endocrine organs? Too low already. It's right below the hypothalamus already. It's right here also. Pituitary gland. Thank you. Right. Now, the pituitary gland releases. Oh, yeah, yes, it does ADH. But in this story, it is growth hormone. Now you know why this one is called growth hormone releasing hormone. It is a hormone that says release growth hormones. Okay, right? So if you think about this, let's say you are trying to during your adolescence, you are trying to grow up. This signal is being released, so therefore you can grow up. Straightforward, this one. Okay, so hypothalamus is the first level. It says, hey, time to grow up. I release this to stimulate this to release this. This one a lot, you grow larger. Can? Okay, but if you're at this size already, I don't want to grow any larger, right? So therefore, once, for example, this one hits maximum units already, once you have a maximum level in the bloodstream, this will actually send a signal to say, stop releasing. It doesn't make sense for it to inhibit itself, isn't it? Cannot be GH inhibit the pituitary gland which releases GH. So it has to inhibit further upstream. It's just like if you all don't want your teacher to give you weighted assessment, you tell your teacher no use. Tell principal. Okay, don't do that. Okay, but that's the idea here, right? So when you have enough GH already, when the body recognizes that you have grown to a proper mass already, you will send a signal to the hypothalamus to stop releasing GHRH, and without GHRH, the pituitary will stop releasing GH. Can we understand this story here? Right? So the specific idea here, the specific words here, doesn't matter. It is the idea that I want you all to understand this. Okay, so this brings us to C being the correct answer. Okay, because product 2 inhibits organ 1 and product 1 stimulates organ 2. Okay, yes. Inhibit means to stop. Okay, inhibit is to stop, stimulate is to start. Maybe you can use that. Okay, to inhibit, to restrict, to prevent. Okay, now we have ADH. ADH is released by what organ in the body? ADH is released by what organ in the body? The pancreas. The pancreas releases a lot of hormones, but not ADH. The liver does not release hormones at all. ADH released by pituitary gland. Okay, please keep this in mind. The pituitary gland is the one that releases ADH. Alright, so keep this in mind. Released by the pituitary gland. And what is the function of ADH? Function of ADH. Function of ADH. Hi, help me out here, please. So if I increase permeability, what is the result of that? Greater absorption of water. Wonderful. Now, when we think of absorption of water, I'm absorbing it from, what am I absorbing it into? Say more permeable, more water can pass through. Okay, absorb from where to where? So the words distal convoluted tubule and collecting ducts are the where, but from what into what? Glomerulus far away already. We are at the tail end already. Collecting duct is tail end already. From what fluid do I absorb more water into what fluid? I heard an answer. Blood. Is it the from or the to? It is the to. What am I absorbing it from then? We haven't formed urine yet. Sorry? The word is something fluid. Body fluid! Everything body fluid like that. What is that fluid formed from? Okay, back to your suggestion. You talk about glomerulus, isn't it? What happens at the glomerulus? Ultrafiltration. What do I produce via ultrafiltration? Glomerular filtrate. I am absorbing more water from the filtrate into the bloodstream. The filtrate is what eventually becomes urine. Okay, right? So over here, looks like we need a better recap. So we're just going to quickly jot this down over here. Increases permeability. Wonderful complete answer, by the way. Thank you. All right, of the distal convoluted tubule and collecting duct. Distal convoluted tubule and collecting duct to water. And then secondly, is going to Jingxue on your left. Hi. Help me out, please. From where to where again? Yes, you. Yes, you. Right. Yes. Where am I going to absorb more water from and into? We just went through it. No, not glomerulus filtrate. Glomerulus is a thing by itself. Right? So please move along with me. From glomerular filtrate to bloodstream. Right? If you wish to cut down, you can just go straight to filtrate will do. Okay? So just from filtrate to bloodstream. So if I know that ADH does this, more ADH, more of this, less ADH, less of this. Okay? Okay, so I hope you all realize right now I love writing things down because it allows me to not have to clutter in my head. My head is better for thinking. I write stuff down for the remembering. Okay, so that can be a strategy for you as well. Now we are looking at hot and dry desert. I need to conserve water. What else do we need to do other than conserve water in the desert? Here, tell me conserve water already. What else do we need to do in a very hot and dry place? So this conserve water answers this part. Hot how? Hot place how? Thank you. Sweat more. You have to sweat more. So in a hot place, okay? But sweating is also a means of losing water, isn't it? So therefore, do you think like, wow, very hot place, I need to sweat more, but I not enough water, I sweat less. How? So therefore, I only have one means of losing heat. Sweating is our biggest way of losing heat. In fact, we are the best sweaters on earth. We sweat the best. That's why our brains can become so big. Compared to all our mammalian counterparts, right? Our brain to body size, our brain very, very big. It's only because we are very good at losing heat. And the biggest way to do that is through sweating. Right? So we cannot say like, hey, don't sweat, it's okay, I keep water. Then you're just gonna boil up inside. Okay? So we definitely have to sweat more. So we have to use other means of losing more heat. So therefore, this brings us to our collecting duct length and the rate of ADH secretion. Okay? Sorry, I forgot your name. Jiaxing, come, help me with this, please. Between A and B, we will choose B. Why B? Okay, don't panic. Okay, basically, more ADH, more of this. And if the longer my collecting duct, I can have more of this occurring as well. Okay, so it's a twofold adaptation. Okay, wonderful. Right, this will be something that we see in what we refer to as a kangaroo rat. Sure. Yeah, very common animal there. Okay, awesome. We're done with question 5. Let's move on. We're looking at question 6 now. Hormones. Carried by, destroyed by. Pretty straightforward question here. Erica, help me out, please. Carried by plasma and then destroyed in the liver. Absolutely correct. What does the kidney do then? Excrete. You say excrete? Thank you. Yes. Okay. So liver destroys it. The kidney excretes whatever we don't need. Okay. Right. Wonderful. So answer is B. Moving on to question 7. Okay. You all haven't do repro yet, right? It's cool. Only lower side do a bit lah, right? But all the hormone stuff haven't do yet. Reproduction. Okay, so even if you haven't done that, here we have this under reproduction in humans. Okay, so here we have, okay, actually I would like you all to look at the spelling. We follow British spelling. Alright, we follow British spelling, it's OES, but it is still pronounced the same way. Just like how you pronounce this thing. It is not the gullet, but the yes, I know that my Adam Settle is very pronounced, but I'm not looking for that. It is not the gullet, but the what? Okay, so it is spelled with but pronounced without the first O. Esophagus. And therefore this is also estrogen. Okay? Okay? Right, so even if you ignore this one first, MCQ, this is why MCQ shine up. Even if you have stuff that you don't know, look for the stuff that you know first. Right? Okay, reduces glucose concentration. Definitely insulin, right? Adrenaline has been removed from your syllabus, but you all know what about adrenaline? Adrenaline does not make you high. It makes you enter a fight or flight response with increased energy levels and awareness. Definitely not high. Okay, we definitely know that insulin will reduce glucose concentration. So between C and D, we have ADH. You definitely know ADH already, but it doesn't give us a choice. So between dilates pupil. Wow, this one y'all really don't know already. So back to our adrenaline high. I want to bring to your attention that one of the effects of adrenaline secretion, just to share with you, is the pupils dilating. You all learn human eye already. Correct or not? That's the second part of our revision today. If the pupil dilates, what happens? Pupil dilates, what happens? More light enters. Okay, more light enters. Now, when we think about the fight or flight response, when more light enters, you have better vision. You are clear. You can see things more clearly. If it is dangerous, run away. If you think you can fight it, go for it. Right. So that's the idea of adrenaline. Okay. So that's for pupil dilation. Right. But then if adrenaline is not in our syllabus, how do I answer this? Because if you see this at the end of years in your O levels, you will know that estrogen does not do this. Because if not right now, all of your eye pupil will be very big. Estrogen is a female sex hormone. Okay, right? Estrogen is a female sex hormone, right? And it does nothing to the eyes. Okay, awesome. So here we're looking at D. Question 7 is D. All right, moving on. Question 8. I said adrenaline is not in your syllabus already, but I want you to look at the question here. Life saving, if you have low blood glucose concentration, what will be the best way to help you out of that situation? Sugar, right? So it will be what sugar? Like sprinkle the glucose at you. How would I administer that? How would I administer that? You all confirm see, yes, injections, right? That's an IV, the intravenous drip, right? You see hospital, they hang the thing, then they poke, then the thing will go through, right? So if your blood glucose is low, I directly send glucose in a fluid form into your bloodstream. Okay? I don't want to go through any other hormone. I just, enough glucose, I give you glucose. Make sense, right? Okay? This one, same lah. Just drink water, or also the IV does the same thing as well. Okay? But this one, so this is our answer here. Okay? Right? So if you all watch all the medical drama, then the person lying on the bed, then beep, then wow, take the pedal, everything. Okay? Pedals, the electrical charge can only reset the rhythm. It cannot restart the heart. Once the heart has stopped, no matter how much you shock it, you're just gonna barbecue it. You cannot restart a stopped heart with the electrical pedals. What can we do instead? It's chemicals. Adrenaline. In America, they call it epinephrine. Right? So those of you who watch medical dramas in America, you'll recognize 2 mils of epinephrine, quick! These kind of things. Then they will take this thing and just pop like that. Yes. Okay. So adrenaline, epinephrine, they are hormones that kickstart the heart. Okay. So here we're looking at low heart rate. Oh, okay, make a change for me, please. Sorry about that. Your options, are they different from mine? Sorry about that. Make a change for me, please. Thank you for pointing it out. Okay, basically, adrenaline is only used for this. That's all. Okay, ignore the options also because adrenaline not specifically in your syllabus. But we're using this to learn about This one, just administer glucose, just administer water. Okay? Awesome. Let's go. Okay, again, we have ADH over here. The drug that we are focusing on is diuretic. So we have anti-diuretic versus a diuretic. Do you see that? Okay, ADH, the anti-diuretic. Then you have a diuretic. So quite obviously, the name here tells me that they're going to work in opposing actions, isn't it? Opposing, they're going to oppose each other. And they tell me already, reduce the production of ADH. What's the effect of diuretics on the kidney? With more diuretics, what happens to ADH? Less ADH. And therefore, once you have more diuretic, less ADH, you think about this, do I absorb more or less? Less ADH, we're looking for less. Okay? Right? Keep things simple, one at a time. More diuretic, less ADH, less water absorbed, reabsorbed. Okay? And with that in mind, what happens to urine quantity and concentration? If I reabsorb less water, that water remains in the filtrate, which forms urine, more diluted urine. Okay? And therefore, to work on our productivity, we're looking at blood sugar, and we have the pancreas and the liver over here. Okay, here we have glucagon as the hormone, which works in opposite fashion with insulin. All right, okay, insulin. Can I take this opportunity to ask specifically where in the pancreas are the hormones released? Come, share me the answer, please. Start with I. Of a person's name. Okay, first and foremost, uppercase L, because it's named after a person, you have to put the uppercase L, just like group of Henle in the nephron. Group of Henle, the H was uppercase also. Okay, now this one, please. Before I write the answer there, how to pronounce this? Island. Okay, say on. How to pronounce this? Thank you. Please not islet. Okay, the islets of Langerhans of the pancreas are the ones that release insulin and glucagon. The islets of Langerhans in the pancreas are the ones that release insulin and glucagon. Okay, the islets of Langerhans are the name of that group of cells in the pancreas. Okay, awesome. Thank you for remembering that. Okay, 1 hour of exercise. How is this relevant to blood glucose regulation? What happens? Excuse me, when you exercise? Energy. Then we have to link it to this idea here, isn't it? How? What's our next step to take? Small glucose, what? So that, okay, then if like that you all say exercise, more glucose, will blood glucose concentration increase? Initially, yes. Your muscles need glucose, right? Your liver will do what? Oh, produce is the wrong word. By doing what? By doing glycogen. What would the glycogen in the liver, what will happen to the glycogen in the liver? Converted into? So if more glycogen is converted into glucose, do I have more or less glycogen now? That's it. You see that? Okay. Okay. Then when I have less glycogen in the liver, this means that glycogen was converted into glucose. Glucose is going to, is it going to stay in the liver? What's going to happen? Doesn't stay in the liver cell. What has it do first? How does it go to the muscle cell? Bloodstream. So therefore, this will result in having more glucose in the bloodstream. Okay, so question is, do I start from the 3 4s, the 1 2s, or the 5 6? It definitely has to be the 5 6 because we're looking at hormonal control. So therefore, is this 5 or 6? So it's 5 4 1. Okay? Okay, we're talking about hormonal control, huh? Hormonal control. Okay. So why so long? 1A, cancel, sorry. Adrenaline not in your syllabus. Okay, so we're gonna skip 1A, ah? 1A. 1A skip because it's on adrenaline. Okay. Now moving on to part B. Thermal regulation. And we are focusing only on human skin. Now take a couple of seconds to browse through the wonderful treasure trove of knowledge in your brain of thermal regulation. What mechanisms in thermal regulation do not involve the skin? What corrective mechanisms in thermal regulation do not involve the skin? Oh, y'all look at me like this question never hear before. Okay, thermal regulation got 5 steps, got 5 corrective mechanisms, 3 of which are in the skin. I'm asking for these 2. Everything is heat. That one is a side effect. It's not a corrective mechanism. Anyone? Be daring to make mistakes. We make mistakes here so that we learn. What are some effects of thermal regulation that do not occur in the skin? Yes, shivering. Yes, shivering. Shivering not a skin thing, it's the muscle thing under the skin. I say thermal regulation. I never say question. Okay, right? So since you talk about that one is for cold, right? Then what is the hot counterpart of shivering? Panting. Yes, panting. Right? Because you release more, you lose that body heat through that warmer exhaled air. Okay? Yes, you do. Yes, you do. Okay. But most often we just describe it as increased breathing rate. Okay. Right. So when it's too hot, increased breathing rate. When it's too cold, shivering. And then so that's actually I classify that as number 5 because those two are drastically different. Number 4 is common in both, just opposite direction. Yes, metabolic rate. When you're feeling very warm, metabolic rate does what? Increase or decrease? Metabolic rate basically the rate of metabolic reactions in the body. As a rule of thumb, metabolic reactions in the body always generate heat as a byproduct. So if you're feeling warm, you push that metabolic rate up to generate more heat in the body. When you're feeling warm, you lower that metabolic rate. Okay? Can? Right? So these are the 2 things that do not happen in the skin. Question is looking for skin. What are the 3 things that comes to mind immediately? Okay, hair. What about what else? That's it. Well done. Okay. So in terms of question analysis, it's a 5-mark question. We have 3 points here already. Where will I get my first and the 5th mark? Tell me what happens in the sauna, yes? Yeah, we craft it out first. So first marking point, relevance to the sauna. Okay? No, I'm just jotting the points. Yeah, I can write that. Yes, thank you. Okay, so where will be my 5th mark then? I have 4 marks here already. Any guesses where my 5th mark will be? Absolutely, thank you. Temperature lowering back to the norm. Questions asked for thermal regulation. You must then re-emphasize that, hey, I know what is regulation. If you're too high, I bring you down. If you're too low, I bring you up. So our 5th marking point will be on thermal regulation. Here, I'm going to bring it back down to the norm. Okay? All right? So, very quickly, let's embark on our journey here. We're going to talk about what happens in a sauna first. What happens in a sauna? Did we just say sauna hot? You don't need to describe what got steam, everything. What happens to the body in the sauna? What happens to the sauna? How does it interact with its surrounding? Yes, we go straight to that. Body gains heat from the hot air in the sauna. Okay, let's go. I need 3 more words to complete this first sentence. Thank you. Do I go straight into my 3 corrective mechanisms? Yes, thank you. Good talk about your thermoreceptors, isn't it? But we do not need to go into the entire or thermoreceptor sensory relay motor. No need. Question, only ask you to talk about thermoregulation. You say the receptors detect it, stimulating 1, 2, 3. Okay? We talk about the first one, we wrote down sweat, stimulate the. Okay, this is where I want you all to pause and think. Do I say stimulate the sweat glands to release sweat or to release more sweat? Why is it wrong to say to release sweat? Excellent. This may be surprising to all of you, but we are constantly sweating. Even right at this very moment, you touch your skin like, wow, dry. And you are sweating. What is happening is then, therefore, a very low rate of sweating. This is not to say that if you stare long enough, you will see a droplet come out. It's because the rate of sweating is lower than the rate of evaporation. Okay, so you are constantly sweating, and hence we say to release more sweat. It will never be a sweat or don't sweat. Okay, all right. Right, so as we have mentioned just now as well, water in sweat evaporates. Okay. After we talk about sweat, we can talk about our what else? What else? We jotted down just now as well about the hair. What does the hair do? The hair falls. The hair is not the effector. The hair doesn't relax. The muscle is the one that does it. Right? Okay. So this was the story about the jacket I shared with you just now. Okay. And finally, arguably the one that is actually the more important one as well, side by side with sweating, is about our blood. Okay, what happens to our blood? You are looking for specific phrases. Vaso, What was I looking for? Vaso enlarge. Dilate. Right? Vasodilation. Right? Vasodilation. Okay. Anybody first time seeing this? Okay, thank you for your show of hands, right? So allow me to talk a little bit about this then. Okay, dilate, constrict. This one can understand. Which one is the one that becomes bigger? Dilate, constrict is to narrow, dilate is to enlarge, right? To widen, right? We specifically use the word vaso, dilate and vasoconstrict only for the blood vessels in the skin. Only for the blood vessels in the skin, right? So the arterioles in the skin, as we have identified in the diagram previously, when they widen, we refer to that as a vasodilation of the skin arterioles. Okay, because they are arterioles, we need a very special term for that. For all other vessels, you can stick to dilation and constriction. Okay, right? So over here, vasoconstriction. Do I want to dilate or constrict? It is very warm here. I want to dilate, right? Vasodilate to bring more warm blood. What does this allow me to achieve? Absolutely. Thank you for remembering those three phrases. Arterioles in the skin, vasodilate to bring more warm blood nearer to the surface, increasing before you go along, like, hey, conduction, convection, radiation, physics, no need. Okay, that's all you need. You do not need to explain any of these. Okay, conduction, convection, and radiation are just means of heat transfer. That's it. Okay. For those who take physics, this is a bonus for you. You understand this better. But well done. Thank you for remembering that. Okay, conduction, convection, radiation. CCR. Okay, how many marks do we have so far? 4. And therefore, this brings us to our wonderful fifth point. What is it? Wow, temperature return to the norm. Forwards, give you 1 mark. How do we phrase it more eloquently? Right, so keeping in mind that when we have an increasing above the norm, we have 1, 2, and 3 corrective mechanisms coming into play. All you need to do is to sum it up, something like hence body with more heat loss to the surroundings, body temperature turns to. That's it. Okay, just to sum it up, body. From what? Before heat stroke, don't go so drastic yet. Absolutely, thank you. Overheating. All right, and before we flip over, can I just suggest that every time you all copy stuff from the whiteboard, from the screen, right? Can you all take 1 minute to read what you have written? Because just now it was just passive, copy and write only. Now I want you all to read your own beautiful words. We cannot read, then write it down properly. Okay, so take a minute to read your own writing. Make sure you properly understand what you have just written down. Okay, make sure you can properly understand what you've just written down. I'm not going to rush you. I would love for you to read your answer, please, Batman. Thank you. Can. You can. You can say it decreases to the norm, falls towards the norm, falls back, falls down towards the norm. Is the idea. So as you progress in our educational journey, it is less about remembering exactly the words that your teacher says. And if you all can track back 4 years ago, P6, your answers must be exact word to word as what your teacher say. As we move on into our educational journey, it is the ideas that are more important, less so the exact words. Okay? Right, so thank you for that question here. So as long as you can convey that correct message, you will get your mark already. Okay? Okay? Awesome. Let's move on. Question 2. Blood alcohol concentration. So when you all see this question, if you all really forget how to whatever alcohol does really, can we still do part A? Definitely can. Very confident, yes. Help me out here, please. Very sleepy.
Wait, you want me to like say all more?
Answer the question. Hey, come ladies, come. Let's hear from each other, please. Come.
Remains as you. The reaction time 200 seconds. Then you got all the rest the same again.
Okay, so our friend here wants to have 4 sentences. 0, 300, 0, 5, like that. Like that.
Oh yeah. Concentration increases from 0 to 0.15. The reaction time increases from 300 and something, so 600.
Okay, like I said, we are trying to move away from remembering exact words that we have to write down, but rather I want us to be able to convey the message here. Can we see that actually there is 2 parts of our graph here? Let me see that. Okay, you state the baseline first. You state the baseline. 0 alcohol, 0 blood alcohol, reaction time is 300 milliseconds. You state that first. Then we have a gradual increase. And then we have a steep increase. Okay? We have a gradual increase and steep increase. So this will give me 3 marks already. Your first mark is baseline, gradual increase, steep increase. Where will my 4th mark be? I invite you to read the question properly. Where will my 4th mark be? This is evidence really what?
Right.
Overall what? Overall increase, is it? I already say gradual, steep, both are increased already. No. What? The effects of driving. Your 4th mark will be what? The reaction time is 600. Firstly, reaction time increase. Do you get faster or slower? Slower. Some people will get confused. Wow, reaction time increase, you will go faster. No, you take more time to react to a stimulus. So you are now slower. Okay, can we see that? Right? If you take more time to react, you are slower. Right? So our 4th mark will be effect on driving already. Okay?
What? It's so bad.
Okay. Alright, we state our base first. About 50, 50. No, not 0.15. Sorry, the gradual increase is 0.10. 350, yes. Introducing and again emphasizing my point of not having to memorize specific words. Instead of saying gradual increase, steep increase, how else can I represent this data? From 350 to 600, it is almost double. Right? Okay? Reaction time almost doubles. All 3 points over here. 1, 2, 3 is this. Now, our fourth marking point is for effect on driving. So what is the effect on driving? What is our effect on driving here? Crash. Let's say crash. Let's say crash. What happens? Like we said, that reaction time increases, right? So this means that the driver will not be able to respond to obstacles on the road quickly enough. Okay?
Thankfully. So that's actually nice.
Right? And it cause accidents to happen. Huh? In words, you need deciphering. Drivers. Use contact. Okay. Right. Again, right. Make sure you are reading your own words. Don't just copy, and then pick up your phone and look at other things. Really, look at your own beautiful handwriting. Okay. Thank you. And if you are also done with that, we're looking for 2 long-term effects of alcohol consumption. Liver damage. Very good. Wet brain, like 湿. Sorry. Brain is bad. You can't write that. So yes, you can write down liver damage. What else can you write? No, long term, long term. What? I heard something. Did I hear something? Okay, so we're looking for liver damage. You want to talk about brain? Brain damage lah. I heard cancers. You cannot just put cancer. What specific cancers then? Liver damage, liver cancer. Only one liver. You cannot put liver damage, liver cancer. No, not kidney. Sorry? Yes, cardiac issues. Heart problems cardiac issues. So it can target heart, it can target liver. Cancers is usually on the throat. Okay? So cancers. What else? You want to talk about the brain one? Memory loss. Memory loss. Okay? Learning deficiencies. Okay? Right? So alcohol is an exceptionally potent substance because it is one of those substances that can pass through a protective layer around the brain. Our brain is so important that it has its own protective layer that is partially permeable. Many bacteria and viruses cannot pass through that. Thank you for asking. Deficiency. Okay? All right, come, let's move on. Carbohydrate metabolism. Liver. Talk to liver about that just now. During fasting and after a carbohydrate-rich meal. During fasting and after a carbohydrate-rich meal. We have 4 marks here. The separation will be 2 each. That's it. All right, okay? During the fast and after the carbohydrate-rich meal. That's it. Question is asking about role of the liver. Do we have to talk about the pancreas detecting the changes? Do we have to talk about the hormone that it releases more of or less of? Do we have to talk about our dear islets of Langerhans? Oh, no need lah. We just name drop the hormone, talk about the liver, done. Okay? So during fasting, what happens? We have to start there first. During fasting, you cannot just say, during fasting, the liver do this. No, where does it begin? Remember just now in our last MCQ, we have this, always think of the starting point of your story. All right, okay, so during fasting, blood glucose, high or low? Low, how low? Below the norm. So you got to start with that. Okay, you got to start with that, right? Okay, come, let's quickly jot this down. Over here, we're looking at insulin or glucagon. Falls below the norm is glucagon, huh? Very good. If I stop my sentence over here, the glucose is still in the liver cell. What needs to happen to the glucose first? Release in the bloodstream, that's all. You don't have to use the word transport. Okay? Glucagon stimulates liver cells to convert glycogen into glucose, which it, right? So what we have just done here is to kind of have a style that we can follow. We state what happens, where our story begins, and we tell the story. How does it change? And then why does it occur? To increase back to the norm. So here I have false, action, back to the norm. So here, after the carbohydrate-rich meal, I will have increasing above the norm. What is my story? What does insulin do? Here we have a twofold story. Insulin must do something to the cell first before the cell can convert glucose into glycogen. Absorb first. Must absorb more first, isn't it? If I don't absorb more, I will not be able to convert more into glycogen. Can? Okay? Right? So as I mentioned just now, say the story as you wish. Use the words that you wish as long as you state the facts. And with that, thank you. Right, we are done with homeostasis and hormones. Our next handout here will be on nervous system and human eye. As the worksheets are being passed down, anyone wants to ask me any questions first? You can leave it for later on as well. But if you want to ask me, also can ask now. No. Yes. No. Toilet is right outside. Go. You just here. Yeah. The wooden door on your left. All right. Are we ready? Let's go. Shall we? Okay, come. So, for the nervous system, it has been combined with the human eye as well. In this revision over here, because for the nervous system generally, we are only looking at what makes up the nervous system. Oh yeah.
Let's add the one.
Why just now too much? Then now not enough. Okay, wait ah. You all cannot see line X, Y is here. This only you don't have, is it? Only one copy missing ah. Everyone else has the worksheet ah. Okay. Sorry, Xinxian, it's printing now. Okay. All right, come. So if this is line XY, what neuron has been damaged? The sensory neuron has been damaged. So the stimulus of the pinprick will not be sent where? To the brain, right? If the brain doesn't receive a signal, there will be no perception of pain, right? The damage will still be there. The cells will still get damaged, but you will not be aware of it until you actually look at it. Okay, right? So pain felt definitely is a no. Will the arm move due to the reflex? No, but can you move the arm? You can still move the arm voluntarily. Okay, but the question is, did it move from the reflex? No, so we're looking for A. Okay, Again, identifying our neurons. We have P, Q, and R. P, Q, and R. What are these three neurons here? P, Q, and R. P, Q, and R. What are these three neurons here? P is the relay. How do we know that? Got two what? Okay, very good. Right, identifying. Let me help you remember this one. The relay neuron is only found in the CNS. What is the CNS? Yes. Alright. How do you know that is a sensory neuron? How else can you identify that as a sensory neuron? How? Tell me why is that a sensory neuron? There's a circular thing. All the neurons have circular cell body. Yes. So you have to be more specific. The sensory neuron is the only one with the circular cell body outside of the spinal cord. Okay. When we say spinal cord, specifically this part is spinal cord. So these two things are the roots that extend out from the spinal cord. Okay? So the sensory neuron is the only one with the cell body outside the spinal cord. Okay? Whereas the relay and the motor have it inside the spinal cord. To be even more specific, what is the name of this region and this region of the spinal cord? The ribs. Okay, I think this diagram is a little bit better as well, but it's going to be the same thing. Basically, these two parts are not colored, they are not shaded. Even if I shade them, doesn't matter. But basically, can we see that there will always be this inner butterfly structure within the larger spinal cord structure? Can we see that? Okay. The inner layer it's called the gray matter. And this one is the white matter. Now, let me tell you why it's named as such. It is not named due to the colors because in the printing we can shade, we can don't shade, doesn't matter. But more importantly, I want you to think about crowdedness. If you look at this diagram over here, can we see that the gray matter is going to be the more crowded one because it contains the cell bodies of all the relay and motor neurons. So here I'm only showing you one reflex arc. But in the entire spinal cord, there are going to be many neurons there. The cell body is the largest portion of any neuron, and hence, if I have many of these, this part will be the most crowded. And hence, if you think about it, it's very crowded, and I shine a light through it, not much is gonna pass through. Great. Right? So we name it as gray because in an X-ray, when it's actually seen through an MRI, not X-ray, it actually looks darker as well. Okay? But this is not something that's specifically in syllabus. Why I bring this into your attention is just to be able to identify inside the inner butterfly is relay and motor neuron cell body. The only cell body outside is the sensory. Okay? Have I answered your question? Where the sensory neuron is? Awesome. Let's go. So back to this. This one is our relay neuron because it is found in the CNS. CNS stands for wonderful, thank you. Central nervous system is made of only two organs. Brain and spinal cord. How do I spell spinal cord? Oh, okay. Yes. Please take note. Please do not spell it. This is the music one. We're not making music. Mac or chord? Why? What kind of math you're learning now? Oh my god. Oh, nightmares. I was bad at that. I was very bad at that. Okay. Right, please take note. It is not the one with the H. Okay? Spinal cord. What's the difference between the spinal cord and the spine? Thank you. Spine is the bone that protects the spinal cord, just like how the skull is the bone that protects the brain. Okay, so difference, huh? Okay, so I always actually use this in nervous system. That's it. This is the direction of nerve impulse transmission, SRM. Sensory, relay, motor. That's it. That's it. Once you can have this in mind and you identify this is sensory, relay, motor, the answer is going to be RPQ. Okay, no. Yes, RPQ. RPQ is D. Okay? Okay? Oh, I just gave you the answer. I just gave you the answer. You can see, is it C? Is it 1 and 4? Is it 1 and 4? This one is whose cell body? Sensory. And yes, answer is 1 and 4. Here we have sensory only. Here we have relay motor cell bodies. These are the only places you will find cell bodies. Everywhere else, will be axons and dendrons. Okay? Yes, very, very common experiment over here. Just looking for the pathway. Now, question is this, since you all did it right, is this a reflex action? It is not a reflex action. What is it called? It is a voluntary response. Voluntary responses can improve with time. That is the thing. Reflexes, no change. They are roughly always at that timing already. Okay? Right? So in this case here, from the student's eye to the muscles of his hand, ABCD, which one are we looking at? Definitely has to be C and D. What? Why must it start with the retina? Retina contains photoreceptors. Excellent. Thank you. So you must always begin your journey with the receptor. Just like our previous topic, thermoregulation, we begin with the thermoreceptors. Here we begin with our photoreceptors. Okay? So it is the same throughout until here. Do we go to the spinal nerve or the brain? We go to the brain. Why? You all tell me you voluntary really what? The brain must like, oh, ruler falling, what do you want to do? The brain is the one that says, catch it. Sends an impulse to the muscles in the hand to catch it. So it is a voluntary response. A spinal nerve is just a nerve in the spine. What reflex in your syllabus do you learn moves through spinal nerves only? The knee-jerk reflex, patellar reflex is the only one that moves through the spinal nerves only. It does not require brain processing. Okay? Whereas for pupil reflex, what kind of nerve does it go through? Cranial nerves. Thank you. Okay, so any reflex that occurs within the head region, cranial nerves. Anything else? Spinal nerves. Okay? Okay? Awesome. So therefore our answer is C. Brain, spinal cord, spinal nerve. Effect of alcohol. Effect of alcohol on time to catch ruler. Those are the data points. Generally, it increases reaction time, so time taken to catch increases. That's all. Yes, answer is A. Okay, very straightforward. Just now we talked about CNS. Here we have PNS. Everything but the brain and spinal cord belongs to the peripheral nervous system, and hence central nervous system is brain, spinal cord. Every other nervous structure, yes. Every other nervous structure, not the brain or spinal cord, belongs to peripheral nervous system. Okay, so here our answer will be C, 2 and 3. Okay. Human eye, human eye. Okay, this one, I believe your options got different from mine. Okay, but before that, as I mentioned just now,
I don't know what's it called.
X. X, shout out please, X. Iris, thank you. Come, what is why? Hey, do you all use ciliary body or muscle in school? Okay, I tell you, ciliary body contains ciliary muscle, but it's a muscle that contract and relax. So just go straight to muscle. Okay? I see. This is which one? Okay, yes. Sclera, choroid, retina. Sclera? Sclera? Choroid lah. I don't say wrong, I give you options. All right, thanks for trying over here. All right, so just keep this in mind. At the back of the eyeball, we have 3 layers: outermost, sclera, middle, choroid, innermost, retina. Right, that's the photosensitive layer because that's the one that contains the photoreceptors. Okay, sclera, choroid, retina. Okay. I just asked my class this yesterday, so let me ask you this as well. When you look into each other's eyes and you see, wait, let me draw it back. Okay, imagine you look into each other's eyes here, or you look lovingly into your own eyes in the mirror. You look at this part. What color? Okay, firstly, what is that part called? Pupil. So if I ask you what is the color of your pupil, your answer will be? I heard another answer just now. Is it you? What's the color of the pupil? Yes. Who was that? Is it you? Yes. What's the answer? The pupil has no color. What is the pupil? It is a space. It is an opening. It is a hole. Just like how the stomata is an opening in the leaf. Okay? A nothing cannot have a color. So a proper question will therefore be, what color does the pupil appear to be?
Black.
That will be black. Why does the pupil appear black? Yes. Inside, we are looking at the black pigment. The black pigment is on which layer? Sclera, choroid, or retina? Choroid. Okay, the choroid is the black pigmented layer. So when you look straight into someone's pupil, you're looking through the pupil, through the transparent and colorless lens onto the choroid. Okay, well, please keep in mind, I say pupil as a whole doesn't mean that you take something you all the way in, there's a cornea there. Okay, there's a cornea there. Right? Right, so keep this in mind. The pupil appears black because you're looking at the choroid, which is black due to the pigment. What's the name of the pigment? The name of the pigment starts with the letter M. Melanin. Thank you. It is the same class of pigments in our skin, our hair, and our iris. Melanin. Okay, come. So now that we've identified all of this here, iris function. Okay, wait, the iris colors the lens. The iris is the colored thing. This is the iris. When you say, "What this person blue eye, brown eye, green eye," it is the iris that is colored. It's not the entire thing green. Okay? But that is not its function. Its function is to control the size of the pupil, which therefore controls the amount of light entering. The lens has no color. The lens is this thing behind, inside your eye. Can, huh? It's not labeled. I have labeled here already. Né? You're looking through it. If you look straight into someone's eye like this, yes. Okay? Right? So iris controls the amount of light entering the eye by constricting or dilating the pupil. Okay? What's the choroid's function? It is pigmented to do what? There are two functions of the choroid. Yes. Right? The first function due to the pigmentation is to absorb stray light rays, prevent total internal reflection. So any incoming light ray, if there is no choroid, it will do this. Every time it touches the retina, there is one point in which the photoreceptor will generate a nerve impulse. And therefore, we prevent this due to the choroid being black in color. The black color of the choroid prevents light from bouncing so many times. Can? Okay? What's the difference between reflection and refraction? Okay, in blue color, if this is where I shine the light, I start from here. Reflection, you stay on the same side here and you bounce off. You do not go through. Refraction is where the light ray passes through and bends a bit. That's it. Do I assume that none of us here take physics, therefore? Okay, so you understand, Anyone else? Understand, Everyone else now can understand already? Okay, basically your eye cannot reflect light. If your eyes reflect light, then I will be shining at you. My eyes will be like that, shining at you. Okay? You all have seen this phenomenon before. Our eyes do not reflect light. Cats. At night, do you realize their eyes like shining back at you? Yes. Nocturnal predators usually have that because they want to be able to see better at night. Okay? All right? With the R, it will pass through, but it doesn't stay in the same line. It will bend a bit. To refract is to bend. To reflect is to bounce. Is that better way to say it? Okay, so we have found iris, we have found choroid already. That's it. Answer is here already. Okay? Okay, let's move on. Okay, come. Identify again. Identify. Let's go. XYZ. What are XYZ? Yeah, what are those thingies? Identify those thingies. Can someone make sense of this? What is XYZ? Which one is which? Wrong word. Longitudinal is for your esophagus. Ciliary is for the lens one. Round, another word for round is circular and radial. These are the radial muscles of the iris. These are the circular muscles of the iris. Yes, because it's circular. So X is the radial. Y is the circular. What is it? Pupil. Okay. How are the radial and circular muscles of the iris related? What does it mean? Relax. The other word is what? Okay, an antagonistic pair of muscles work opposite. Okay? Yes, I'm hearing the correct thing to learn already. It's just this. What then? The one is lens accommodation. Bright, circular, contract, constrict. What constricts? The pupil. In bright light, the circular muscle of the iris contracts, causing the pupil to constrict. The pupil cannot contract. The pupil is just an opening. Yes? Okay? Alright, so bright light, circular muscle of the iris contract, causing the pupil constrict. Okay? So here we are doing exactly this. Well, our answer will be D for Denmark. Okay? Questions? Contract. In bright light, circular muscle of the iris contracts, causing the pupil to constrict. Okay? Causing the pupil to constrict. Oh, yes, you're right. Okay, Okay, again, looking at the eye. You're just matching them. Matching them. 1, 2, 3. 1, 2, 3. What is 1? What is 1? 1 is what? Iris, thank you. 2 is the? What is 2? Yes, 2 is the sclera. The sclera is the thing at the back of the eye, right? But it wraps towards the front. We see the sclera as the whites of our eyes. The pupil is this. The opening. Okay, 1 is the iris. Alright? Iris, sclera, pupil. So therefore, SPQRTU. Which one is iris? Iris, S. Sclera. Sclera is T. Pupil is U. Okay, answer is STQ. STQ. The difference between R and Q, what are R and Q? Q is the pupil, R is the aqueous humor. Alright? R is aqueous humor. What is its friend? The vitreous humor. Thank you for not saying virtuous, right? Vitreous humor is the one in the posterior of the eye. Both humors perform similar function. What are they? Q is pupil. What's the function of the humor? Very good. Keep the eyeball firm. Okay? Now, this space is filled by a fluid. This space is filled by a fluid known as the aqueous humor. This space is filled by a fluid known as the vitreous humor. The opening here is known as the pupil. Okay, but what occupies the opening is still going to be equal humor. Okay? Can? Alright. Who is the pupil? Okay, come, last one. Now is the lens. This one is your NCC.
Yeah.
Right, so some schools learn this as we have
Screwing job.
what happens to the lens? Between the ciliary and the lens, I have something else. What happens to the suspensory ligaments? Can we say that they why can we not say contract relax? Okay, ligaments are not muscles. Muscles, when they contract relax, they change in length. A contracted muscle is shorter, a relaxed muscle is longer. Right? The ligament is just like your hair. When you pull it tight onto each end, the length of the hair remains the same, whether is it tight or slackened. Right? So therefore, we don't say contract relax, we say pull taut or slacken. Right? In this case here, if the ciliary contracts, I want you to think of the opposite, which is relax. But I can't say the word relax, so therefore you slacken. Okay, so when the suspensory ligaments that are pulling onto the edges of the entire lens slacken, the lens will be allowed to slacken as well. So the lens, what is the original shape of the lens? From the front view is circular, yes. From the side view, by other way of cave is what? By convex. Okay, so in a way it's oval now. Okay, right? So the lens becomes enough.
Yeah, we need to buy right calorie food.
So therefore, moving towards becoming nearer, will lens become thicker or thinner? Becoming nearer, lens will become thicker. Higher speed is A or C? A. That's it.
Okay.
It becomes thicker faster. Higher speed. More curved. Can? Okay?
Yeah, moving line corner brow.
Okay, can I just have your sketch out the rough shape? Just the shape only. If you all are able to do this, what is the shape? Is it an increasing or decreasing? Is it a linear graph? Linear is line. Is it like that? So straight up like this? No, then what? So generally it will still be increasing. How many parts am I going to split it up into? Look at the table. The table gives you all the information. Ladies, I want you all to be able to learn how to use table and form a shape in your head as well. So you look at this. The increase quite minimal, right? Then suddenly, use this, isn't it? Yes, yes. Right, so what we're looking at here will be a general increase. This. In math, this is known as an what curve? Bell curve. Exponential curve. Log is what? Is log this? Log is this, right? I don't know. Yeah, okay, it's just like that curve. This curve is like that, okay? Right? So we're looking at a very gradual increase from 10 to 25. Question. From 10 to 25, gradual increase. Do I say 40 to 60 steep increase? Do I break it up this way into these two circles? No. Can someone help me? Why is this a wrong separation? Why? Come me up there, please. Why is this a wrong separation? Why 10 to 25, 40 to 60 is incorrect? Yes, I need to have the overlap here. If I do it this way, then I'm missing out the data from within. Clear? Right? So in our description, it has to be 10 to 25, 25 to 60. Okay? Right? So gradual, steep. Okay? Gradual and steep. I'll pass you the suggested answer for the graph later on. So just move on from here. So basically here, relationship is from 10 to 25, gradual increase. From 25 to 60, steep increase. Okay? What is near point? What is near point? How near what? It's written over there in your first sentence. So basically, for example, I can see this remote control is saying 21 degrees Celsius. If I bring it closer, 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 up to a certain point, I cannot like focus on the words anymore to make it sharp. That is my near point without crossing your eyes. Right? If you just look at it properly, relax. You look at what? Okay, Mitsubishi. Okay, cannot already. I cannot focus anymore. This is my near point. Okay? Near point increases as you age. Okay? Near point increases as you age. So, what affects near point? Okay? Okay, in you right now, what limits your near point? You're not aging right now, so at this very, very point, what is limiting your near point? What structure in your eye? Near point. The lens. Right? The elasticity of the lens. The elasticity of the lens. The tension that the suspensory ligaments can hold. The amount of contraction or relaxation the ciliary muscles can do. So therefore, anything to do with distance, go straight to all three of these things. It could be something wrong with the lens. It could be something wrong with the ciliary muscle. It could be something wrong with suspensory ligaments. Okay? So that's what near point depends on. Let's see just for the graph one. Alright, so this one from 10 meters. Walk closer. Now, 3 marks. What are our separations? One word, one mark. Describe the changes. What do we begin from? Okay. Question asked for describe the change. If I tell you something changed, you must first know what it was before. So this question says, describe the changes that happens in the eye, and he walked from the 10 meters closer. Hence, your answer should begin from the current state at the 10 meters. Put yourself in this person's shoe. At 10 meters away, what is happening in your eye? As you walk closer, what are the changes that occur? And hence, how does this bring about a clearer image? Okay, so the before and after and the why. So 10 meters away, what is happening in the eye? What's happening in the eye? What are the structures? Which structure do you begin with first? Ciliary muscle. At 10 meters away, ciliary muscles are relaxed. Think of the opposite of relaxed, but I cannot say contract. Hence, taut. What happens to the lens now? If you are more familiar with saying less curve, go for it. Okay, now we talk about the change. As you walk closer. Okay, look for the opposites, but you cannot use that same word for muscles, and hence here we are saying excellent. This is where you get your second point, because what comes next about the lens is where you have your reason. Why do I need the lens to be in this case? Our journey up to here is very straightforward. If this one say relax, here say contract. Here taut, say slacken. Now, lens are thin and less convex. Become absolutely. For what purpose? To see clearer. Not quite. I cannot jump to that. What does the lens do? Refract light. When the lens is thicker and more convex, does it refract more or less? More. Okay, refracts more. Okay. Is it refract more light or refract light more? Why suddenly got more light now? Light more. So remember, okay, just now remember I draw for you the refraction, right? So refraction is bending. If it's thicker, it causes light to bend further, bend more, but it's the same amount of light. Yes. Okay. Do we know what this is?
No. Yeah.
What's focal point? What's the focal point? Is it a thing of the eye? Focal point is not a thing on the eye. Focal point is where the light rays are bent and therefore allowed to meet. Then, if this peak, the focal point, lands on the retina, that is where we will form a clear image. Yeah. No. Okay, all right, come. So let's quickly finish up that last few questions here. So again, just make sure we can remember not just the answers. Don't just come here and just copy stuff down only. Learn how to understand the question. Question says, describe the change. Tell me the before and after and the why. Why does this change need to occur? Okay? All right, come. Come, few seconds. Read these two paragraphs, please. Very, very quick one.
I'm so wrong. So I'm thinking that let's hear that. I don't know what can it be, but
Read where the watch read down.
are you sure it's that?
Wait. Hey, this paragraph is irrelevant. It's just the header paragraph. Yeah. He did not run to the slash test. Fire! Slash test. Okay, ignore that slash paragraph here. Okay, so yeah, that's it. What are K and L? What are K and L? K is the relay neuron, L is the motor neuron. Please make sure you write down the word neuron as well. Don't just motor and relay. Okay, K is the relay neuron, L is the motor neuron. Electrical and chemical in nature. Do we know what signal is electrical, what signal is chemical? So what do we call the name of the message? that is transmitted, nerve impulses, right? So I'll get to that. Nerve impulses is just a general name for the message. Okay? Nerve impulses in the neuron is electrical. Nerve impulses between the neuron across the synapse is chemical. Okay? So over here, we are looking at this one, you say relay, right? So between S and R, this one will be inside you have electrical, electrical, electrical.
My answers. Yeah.
Nerve impulse, the nature of the nerve impulse within the neuron is electrical. The nature of the nerve impulse between neurons is chemical. What is the general name of this message that is sent across the synapse? You may have heard of this as your yes, right? Okay, all these things, your TikTok or whatever, these things are it's just popularized and make like viral only. These are neurotransmitters. And yes, these two especially are involved. No, wrong. These two especially are involved in what we refer to as the pleasure center in the brain. Right? Whenever you see a stimulus for happiness, you eat a food that you like or whatever, the pleasure center pathway is activated. Yes, neurotransmitter is a chemical one. The electrical one is just if you go to A, you will learn. No need. No need to remember this one. No need. Okay, don't need to remember. Alright, so the chemical signal one will be outside. It means outside the neuron already. So if you look at this, S, R, M, how does the motor neuron stimulate the target organ? It is through the neurotransmitter. Okay, so for the chemical, it's only 3. Okay, so for the chemical, it's only 3. Now, for this one, there are only 2 types of effectors that we learn. What are they? Effectors can only be muscles. What is this? Or gland. Ooh, what is it? Glands. Okay, so when a motor neuron stimulates a muscle, you will just say stimulates the muscle to contract or relax. When you talk about a gland, oh, the motor neuron stimulates the gland to release more, release less. That's it. Okay? All right, and 1, 2, 3, here 4. Okay? Now, another body response not mentioned in the passage that occurs as a result of the fire alarm. So other than heart rate increasing, what else needs to increase? Okay, can you all tell me why heart rate increase first? For what purpose? So therefore, when you want to supply more blood, you want to bring more oxygen there, breathing rate increases. That's it, very straightforward. Okay, you can have breathing rate increases. You can have rate of respiration increases. Okay? But yes, this is actually also due to adrenaline. So you can also say pupil dilation. Okay? But we stick to what we definitely know of. Breathing rate increases, rate of respiration increases. Okay? Part 2 is, what is part 2 for? Why does heart rate increase? Why does breathing rate increase? Well, yes, but think of the run, think of the sprint. He needs more. What exactly needs more energy in his body? The muscle cells. So you want to supply the muscle cells more oxygen and you do not supply energy in the bloodstream. Oxygen and glucose, thank you. So that the muscle cells can undergo a greater rate of respiration and release more energy for the run. Okay, so let's put a pin on that first. I'll pass you the answers later on. What? This one, not reflex. Why not? Why is this run not reflex? He chose to run. How else can we describe that? It is voluntary and conscious. So when the question is asking you, why is this reflex? Why is this not reflex? Always back it up with the definition of reflex. So if you think of definition of reflex, there are three parts. Can you tell me what they are? Immediate response, specific stimulus, and unconscious. Without conscious control. Okay? So in this case, when he heard the fire alarm, you said he chose to run. It was a voluntary response. This means that his brain processed and made a decision. Okay? Because fire alarm ring, you can choose to not run also. Please don't. I always choose to run. Okay? Right? So that is all we have for today here. Let me be answer keys here. If you think you do not need it, then don't take it. Okay? Right? Two copies are one for each of the handouts. As we are handing this thing out, anyone want to ask me any questions first? For your 4 topics here? Yeah, muscular contraction. But it's only like the legs, not the arms or whatever. Okay. All right. So as a closing thing here, make sure that we look through your notes and these questions here that I've shared with you here. If you are interested, I have a pure bio class on Wednesdays at 5, and I'll be opening one here at this time slot as well, Thursdays at 5 as well. So if you are interested, you can just reach out to the chat and just add me in the group chat that we are all in, that big one. Okay, just ask are you all like taking classes here already? Yes, no? Right, so if you're interested, you can just look me up here. I'll be opening up a class exactly this time slot here. So if you're interested, you can hang back and check with me for more details. But if not, all the best for your WAs and your O's if I don't see you again. And for those at home as well, I hope you had a good revision with me. I will see you all next time. Bye.